Hello everyone, welcome back. So we are doing Geometry for CAT series. And in Geometry for CAT series, today we are going to learn about similarities in triangles. Now what do we mean by similarities in triangles? So let me tell you a real life example. Do you order something online? Okay, so sometimes it happens that you imagine that the size of this thing, something, it could be your shoes, or it could be a shirt, it could be a pant, or anything. So you order something by assuming that the size of this thing is appropriate, but when you receive it, you get lesser size or bigger size, but everything is same, the representation is same, the formation is same. So this is what similarities is all about. We have two different kind of triangles, triangle 1 and triangle 2, something like this. So you can see both of these triangles are of different size. Let's say this is triangle A, this is triangle B, and this is triangle C. This is triangle D, E, and F. Now, both of these triangles are of different side lengths, different perimeter, different areas, but ultimately the formation of these two triangles are same. The ratio of their side lengths are same. The angles are same. So basically, whenever two triangles are similar, let's say if triangle ABC is similar to triangle DEF, then what we can say, if triangle ABC is similar to triangle DEF, then this angle B will be equal to angle E. A will be equal to D. Now remember, in that order, okay? In that order, A, D, B, E, then C, F. F, angle F will be equal to angle C. So we can write it here that angle A will be equal to angle D. Angle B will be equal to angle E, and angle C will be equal to angle F, in that order. Now remember that if this is something different, something like, let's say that the order is something like this, that angle A is equal to angle E. Okay, if this angle is theta, this angle is also theta. Angle A is theta, then angle E is also theta. Angle D is equal to angle C. So sum of all the three interior angles of a triangle is equal to 180 degrees. So if two angles are of equal measurement, third will be automatically equal. So in that case, we can say that angle F will be equal to angle B. In that case, triangle ABC is similar to triangle DEF, but you should write it in corresponding ways. What is that corresponding way? That triangle ABC is similar to triangle. Now see, angle A is equal to angle E, so you should write E. Angle B is equal to angle F, so you should write F here. And rest angle C will be equal to angle D. So with this, what happens? Because if you write in this way, you get the correct side ratio. So in that way, we can say AB upon EF. I have taken the first two letter, take the first two letter. Then this will be equal to BC upon DF or FD. Then we can say AC upon ED or DE. This is equal to, let's say, M by N. Now, if you write triangle DEF here instead of EFD, you will get the wrong ratio. So remember that order is very important, that one triangle is similar to other triangle, then in what order vertices should be there, so that you get the correct ratio of sides. Now, if the two triangles are similar, then corresponding angles will be equal. The ratio of their side lengths will be equal. Apart from that, we can also say that all the linear lengths. What are those linear lengths? In a triangle, linear lengths are perimeter. So we can say that perimeter of triangle ABC divided by perimeter of triangle DEF. Now in this case you can write DEF, doesn't matter. This will be same as the ratio of side length, which is m by n, and this will also be same as the ratio of their circumradius. This will also be same as the ratio of their circum in radius and circumradius. Also the corresponding medians, means the median to side A, or the median drawn from angle A. If this is a median drawn from angle A and the median drawn from angle E, these two will be equal. If this is M1, this is M2, then M1 upon M2 will be M by N. The corresponding ratio of the altitude drawn from vertex A will be in the altitude drawn from vertex A to the altitude drawn from vertex A will be in the same ratio. So all the linear lengths, the ratio of linear lengths in a triangle will be of same ratio as their side lengths. But one thing, that is area. Area of triangle ABC divided by area of triangle DEF will be equal to square of the side ratio. Square of the side ratio. So the side ratio is m by n. So area of triangle will be in the ratio of m by n whole square. So remember this one, okay? Now, how do we prove that two triangles are similar? So one of the method is SAS, means the ratio of two sides are equal and the angle between them are also equal. Then you can say that two triangles are similar. The second method is ASA. In this case, two angles are equal and the ratio of their side is given in that case. So basically ASA is nothing but AA. We can say if any two angles AA are equal, then third angle will be automatically equal. In that case, triangles will be similar. ASA is used for proving the triangles are congruent. Now, the third way to prove it is SSS, means the ratio of all three sides are equal, just like this. If this is given, then triangle is similar. If this is given, then triangle is similar, and all the other properties will follow. आ गई बात समझ में? Now let's go to the questions. First question, it says in the triangle ABC, AD and BE are altitudes and EC is equal to 12. So triangle ABC, AD and BE are altitudes. So AD and BE are altitudes. This is D, this is E. EC is given, which is 12 centimeter. CD is given, which is 8 centimeter. And A is given, which is 4 centimeter. So what do we need to find? We need to find the length of BC, or if you are able to find BD, we can say that what will be the length of BC. So how do we do this? Now, let's check two different triangles. Triangle ADC. Triangle ADC and triangle BEC. Okay, triangle ADC and triangle BEC. What we can say, that angle D is equal to angle E, which is equal to 90 degree, right? Then angle C is equal to angle C, which is common in both triangles. Angle C is common in both triangles. Then if two angles are equal, can we say third angle will be automatically equal. So we can say that triangle DEB will be similar to triangle. Now with respect to D, one of the triangle was ADC. Sorry, one of the triangle was ADC. So let's write A, D and C will be similar to triangle. Now instead of D, we should write E here. Instead of C, we should write C, and the remaining vertex A will correspond to B. So this should be the order. Triangle ADC is similar to triangle BC. Now what we can say, if these two triangles are similar, we can say AD upon BE is equal to DC upon EC, which is equal to AC upon BC. Now what do we want? We we want BD, right? We want BD or we want BC. So let's try to check which lengths are known. So we know AE, right? Or we know AC. So AC is known. Then we know EC. EC is known. Then we know DC. DC is known. So can we say that from here BC will be equal to AC into EC divided by DC, or we can say BC will be equal to, what is AC? AC is nothing but 12 plus 4, 16. What is EC? EC is nothing but 12. And what is DC? DC is nothing but 8. So this gives us 12 into 2 or 24 centimeters. Okay. So our answer is option C here. Now let's go to the next question, which says in triangle ABC, BC is 12. BC is given 12, DC is 8 and BD is equal to 6. BD is equal to 6. If angle BAC, this angle, is equal to angle BCD, this angle, then what is the ratio of the area of the triangle ADC to that of triangle BDC? So अब देखो यहाँ पे क्या हो रहा है कि ट्राइंगल, अगर दो ट्राइंगल हम कंसीडर करें, कौन से दो ट्राइंगल? ट्राइंगल ABC एंड ट्राइंगल, तो एंगल ट्राइंगल BCD पे आओ, आ जाओ BCD पे. कैन वी से एंगल A is equal to angle C, so write down C here. Angle B is common in both the triangles, so write B here. So D will come here. So can we say, again taking the side ratio, that AB upon BC is equal to AC upon BD, which is equal to AC upon DC. Now check this out. Do we know AB? No. Do we know BC? Yes, BC is 12. Do we know AC? AC is not given. BD is given. Do we know AC? AC दो बार आ गया यहाँ पे, दो बार तो नहीं आना चाहिए, है ना? This should be AB upon BC, then AC upon CD. Okay, AC upon CD is here, then BC. This should be BC. One second. This should be BC. Okay, so BC upon BD is equal to AC upon CD. ये आ गया. अब हमारे पास कौन कौन सी लेंथ है? हमारे पास CD है, वी हैव BD एंड वी हैव BC, राइट? और क्या है? और यही तीन लेंथ है. तो एक चीज देखो यहाँ पे कि ये जो रेशियो है BC अपॉन BD क्या है? BC की लेंथ कितनी है? व्हाट इज द लेंथ ऑफ BC? BC is 12 and BD is equal to 6, that means 2:1. So the side ratio is given. Ratio of the side is 2:1. Can we say that ratio of area of triangle ABC divided by area of triangle BCD will be equal to square of the ratio of the sides, which is equal to 4/1. Means if I take area of this triangle as x, the whole triangle will be 4x. That means area of triangle ACD will be 3x. So what do we need to find? We need to find area of triangle ADC divided by area of triangle BDC. So this is equal to 3x and this is equal to x. So what do we get? It's nothing but 3:1. So our answer is option B. Okay. Now let's go to the next question. In a triangle ABC, the length of the altitude AD is 15. This length is given, which is 15. And this altitude divides BC such that BD is to DC is 7 is to 25. Means if this is 7x, this is 25x. Right? Find the length of a line segment parallel to the altitude which bisect the area of the given triangle ABC. So basically it says that this line EF is such that it bisects the area of triangle ABC. Means if I take, see, using the ratio concept, that in a triangle the ratio of the base is equal to the ratio of corresponding area of triangles, right? So can we say area of triangle ABD, if I take area of triangle ABD, triangle ABD is equal to 7A, and area of triangle ADC will be equal to 25A. In that case, can we say that area of triangle, whole triangle ABC will be equal to 7A plus 25A, which is equal to 32A. And what is area of triangle EFC? So EFC will be equal to half of the triangle ABC, so which is 16A. So if this is 16A, now think about this. It says that this altitude divides BC such that is, find the length of the line segment parallel to the altitude. So these two lines are parallel. If these two lines are parallel, can we say this angle will be equal to this angle? This angle will be equal to this angle, and angle C is already common in triangle EFC and triangle ACD, right? These two triangles will be similar. So can we say triangle ACD will be similar to triangle ECF, right? Now what we need to find? We need to find length of the line segment. We need to find EF, right? We need to find EF. Now what is ratio of their areas? Like ratio of area of triangle EFC or ECF divided by area of triangle ACD. This is equal to, so this is 16A, this is 25A, which I can write A cancel out, or 4/5 whole square. So can we say that side length, the corresponding side length, so EF upon AD will be equal to 4/5. The ratio of area of two similar triangles is square of ratio of the lengths of the corresponding sides. So EF by AD is equal to 4/5. We already know that what is AD. What is AD? AD is 15. Can we say EF will be equal to 4/5 into 15. So 3 times, this gives us 12 centimeters. Right? So our answer is option A here. It's a really good question based on similarities. Otherwise, solving this question could be a little headache. Now, let's go to the next question. It says in the triangle ABC, D is parallel to BC. D is parallel to BC. As soon as you see this, that D is parallel to BC, we can say triangle ADE will be similar to triangle ABC. Triangle ADE will be similar to triangle ABC. Why? Because whenever we have two parallel lines, this angle will be equal to this one, and this angle will be equal to this one, right? And angle A is already common. Now it says G is the centroid, lies on triangle D. So let's say somewhere G is here. G is the centroid which lies on triangle on line DE, where AB is equal to 7 centimeter. So AB is given. AB is 7 centimeter. This length is given. Okay. And AC is equal to 13 centimeters. So this is also given. And DE is equal to N. Length of D is given, which is equal to N. Now it says which of the following is not the possible values of N. Which of the following cannot be a possible values of N. So let's check. Can we say G is the centroid, right? G is nothing but the centroid. If I draw a line from A which goes through G, what we can say about this? Can we say this line is nothing but the median of this triangle, right? This line, let's say this point is P. So AP is nothing but the median, because G lies on median, right? G is the centroid. What is centroid? Centroid is nothing but intersection of medians. We have already done 4 sessions on lines and points in a triangle, so you should watch those if you are not familiar with this term. Okay. Now, what do we know about centroid? That centroid divides a median into 2:1 ratio. That means, okay, 1 second. That means we can say that AG upon GP will be equal to 2/1. Now think about this. These two triangles are similar. So AG is to GP is 2:1. Can we say that AD upon BD will also be 2:1? So we can say this prompts that AD upon BD is also equal to 2:1, which is same as AE is to EC, right? Because line D, E and BC are parallel. So whenever we have two or more than two parallel lines, the corresponding ratios are equal. Ratio of the segment, like if this is A, B, C, this is D, E, F, then we can say if three lines are parallel, AB upon BC is equal to DE upon EF. Okay, so this is what I am using. DE is parallel to BC. You can imagine a imaginary parallel lines here, a line which is parallel to this. Can we say now this? That's AG is to GP will be equal to AD is to BD is equal to A is to EC, which is equal to nothing but 2:1. So can we find now what we can say about two similar triangles? That ratio of corresponding side lengths or any linear lengths are equal, right? So what is AD upon AB? Can we say that AD upon AB, this should be same as D, the third side, D upon BC, which is equal to, now AD, if I take AD 2, this will be 3, right? AD upon AB is equal to 2/3. So D upon BC will also be 2/3. So can we say that D will be equal to 2/3 BC? But our work is not done here. Do we know what is the length of BC? No, we don't know. But we can find out range of lengths that BC can take. So what is the range of length that BC can take? In any triangle, a side length is more than the absolute difference between the other two sides. So AC minus AB is 6. So BC should be greater than 6 and less than the sum of other two sides. So 13 plus 7 is 20. That means we can say 6 times 2/3 BC. So we need to multiply 2/3 here. We need to multiply 2/3 here. So 2 by 3 VC will be more than, this is 2 times, so 4 and less than 40 by 3, or we can say DE should be greater than 4 and less than 40 by 3. Now if you check this, DE can take any value which is greater than 4 and less than 4 by 3. If you check the options, 4 is not possible. Rest of the other lengths are possible. So this is an amazing question which uses multiple concepts of triangles, which involves similar triangles, which involves properties of centroid, properties of medians and all that. Now let's go to the next question. In the given figure, AB is equal to 4 and CD is equal to 12. Find the length of XY. We need to find the length of XY, this length. Now, it should be mentioned here that these are perpendicular lines. These three lines are perpendicular on B side length BC. So AB is perpendicular to BC, XY is perpendicular to BC, and DC is also perpendicular to BC. Now remember, can we say that if these three are parallels, all of them are working as perpendicular lengths, so these three are parallels. AC is parallel, not AC, it will be AB. AB is parallel to XY, which is also parallel to DC. Now, if these three are parallels, can we say that triangle ABC will be similar to triangle XYC, which will be similar to triangle DCB? Triangle ABC will be similar to triangle XYC, which is similar to triangle BDC. Or we have started from A and then X, so it will be DCB. Using this, we get a very important relation with respect to the length of XY, that 1 by AB plus 1 upon DC is equal to 1 upon XY. Now remember this and try to find out why is this relation coming here. Now you don't need to do anything but to use the similarity. So if you get this, let me know your explanation in the comments, okay? Now if I use the values here, what will happen? That 1 by XY is equal to 1 by AB, which is 1 by 4, 1 by CD, which is 1 by 12, which is equal to, we can take 12 LCM, 3 plus 1, so 1 by XY is equal to 4 by 12, which is equal to 1 upon 3. So 1 upon XY is equal to 1 upon 3, or we can say XY is equal to 3. So that is your answer. Now there are multiple ways that this question has been given in the past in every type of competitive exams. Okay, one of the scenarios is there are two different poles. Okay, from one pole a wire has been tied to the bottom of other pole, and from other pole of a vertex of other pole another wire has been tied to the bottom of first pole. Then there is a situation where two wires are touching each other, intersecting each other. So at what is that height of that point from horizontal? So same scenarios. That question will be also solved using this formula. Okay. So I hope you understood what similarity is, okay, and how to implement them in the questions. So I will try to bring more questions on similarities with some amazing solutions. So thank you.